Hello students, myself Dr. Shweta Rai, Department of Mathematics, Acropolis Institute of Technology and Research. My mail ID is this shwetarai@acropolis.in. In previous lecture, we have already discussed about the convergence of the series, and in this lecture, we will discuss about some tests for the convergence or to testing the convergence or divergence of the infinite positive series. First, P-series test, and second one is comparison test. Here, first we will discuss what is the P-series or auxiliary P-series or auxiliary series. A series of the form summation of n is equal to 1 to infinity 1 by n to the power p, or 1 divided by 1 to the power p plus 1 divided by 2 to the power p plus 1 divided by 3 to the power p, and so on. This particular type of series is called P series or auxiliary series. In this series, if p is greater or equal to 1, in this series p is greater than 1, then series is convergent. Series is convergent. If if p is less than or equal to 1, then series is divergent. Series is divergent. Let us see some examples. First, summation of n is equal to 1 to infinity 1 by root n. Or we may write 1 by root 1 plus 1 by root 2 plus 1 by root 3, and so on. Clearly, the value of p is equal to 1 by 2, which is less than 1. Then series 1 is divergent. One more example. Summation of n is equal to 1 to infinity 1 by n, or we may write 1 plus 1 by 2 plus 1 by 3 up to 1 by n, and so on. Here the value of p is equal to 1, and we know that for p is equal to 1, series 2 is divergent. Let us take one more example. Summation n is equal to 1 to infinity 1 by n to the power 2, or 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by n square, and so on. In this series, the value of p is equal to 2, which is greater than 1. Then series 3 is convergent. Now we will discuss about the comparison test. Comparison test. What is the comparison test? Let us take two series, summation un and summation vn are two positive infinite series, and limit n tends to infinity un divided by vn is equal to finite and non-zero. Zero. Where u and vn are the nth terms of the series un and and Vn. If this condition is satisfied, then the series, then both the series, both the series summation un and summation vn have same behavior, have same behavior. That is, if summation vn convergent implies that summation un convergent. If summation vn divergent implies summation un divergent. Hence, it is clear from the name comparison test, it is clear that it is the comparison between two series. Here, summation un and vn are two series, two infinite positive series, and satisfy the condition limit n tends to infinity un divided by vn, finite and non-zero condition. Then the series un and vn have same behavior. This is the comparison between two series. One series is depend on the another series. First, take an example. Test the convergence of series 1 plus 1 by 3 plus 1 by 5 plus the term is 2n minus 1 and so on. Here, this is an infinite positive series. In this series, the nth term of un is equal to nth term of the series, which is un, that is un is equal to 2n minus 1. Un is equal to 1 divided by 2n minus 1. Now choose Vn. Here Vn is equal to n to the power highest power of n in numerator of un divided by n to the power highest power of n in denominator of in our example, the highest power of un in the term of highest power of un in the numerator of un is 0 and in denominator of un is 1. So Vn is equal to 1 by n. Now we check the condition limit n tends to infinity un divided by Vn. Here limit n tends to infinity un is 1 by 2 n minus 1 divided by 1 by n. Now simplifying, we get limit n tends to infinity 1 divided by 2n minus 1 into n divided by 1, or we may write limit n tends to infinity n divided by 2n minus 1. Here, if we directly substitute the limit, then we get infinity by infinity form. So we cannot directly put the value of n as infinity. For this, we will apply L'Hospital rule, or in another way, we take n as a common from numerator and denominator. Limit n tends to infinity, limit n tends to infinity, n divided by, take n common from the denominator, we get 2 minus 1 by n. This is it, infinity by infinity. Now, on simplifying, we get limit n tends to infinity, 1 divided by 2 minus 1 by n. Now, we substitute the value of n as infinity, then we get 1 divided by 2 minus 0, because 1 by infinity is equal to 0. Therefore, we get 1 by 2, which is not equal to 0. Here, the condition is satisfied, so we can apply the comparison test. For testing the convergence of Vn, here summation of Vn is equal to summation of 1 by n by P series test by P series test. The value of P is equal to 1, and we know that for P is equal to 1, the series is divergent. The series is divergent. And if the summation Un, if the series Vn is divergent, then the series Un is also divergent by comparison test. So we conclude that summation Vn is divergent, implies that summation of Un is also divergent by comparison test. Now let us take one more example. Summation of n is equal to 1 to infinity root n divided by n square minus 1. In this series, the nth term of the Un is equal to root n divided by n square minus 1. With the help of this Un, we can choose Vn. Here, choose Vn is equal to n to the power highest power of nth term in the numerator of Un, which is 1 by 2, and in denominator n to the power highest power of denominator in the denominator of Un. So in the denominator, the highest power of n in the Un is equal to n to the power 2. So we get 1 n to the power 1 by 2 minus 2, or n to the power minus 3 by 2, which we can write n to the power 3 by 2. Now we take the condition limit n tends to infinity, limit n tends to infinity, Un divided by Vn, limit n tends to infinity, Un is root n divided by n square minus 1, and Vn is 1 divided by n to the power 3 by 2. On rearranging the terms, root n divided by n square minus 1 into n to the power 3 by 2. Here, if we directly substitute the limit, then we get infinity by infinity. So, we can write this term n to the power 1 by 2 plus 3 by 2 divided by n square minus 1, or we may take common here 1 by 2 and 3 by 2. 1 by 2 plus 3 by 2 is equal to n to the power 2, and in denominator we take common n square, then we get 1 minus 1 by n square. N square. Now on simplifying, we get limit n tends to infinity 1 by 1 minus 1 by n square. Now we substitute the limit, then we get 1 divided by 1 minus 1 by infinity, or 1, which is not equal to 0. Now all the conditions of comparison test are satisfied. Now then we can apply the comparison test. First we check the behavior of series summation Vn. Here summation Vn is equal to 1 by n to the power 3 by 2. In this series, the value of p is equal to 3 by 2, which is greater than 1, and we know that for p greater than 1, the series is convergent. And now by comparison test, we can say that summation ul, that is series ul, is also convergent. Finally, we conclude that here summation Vn is convergent. Convergent implies that summation ul is convergent. So, with the help of these two tests, we can test the many infinite series if either the series is convergent or divergent. Okay, thank you. Have a nice day.